Today, we're talking about string theory, but first, you need to know what the molecular nature of a substance is. Now, to know the molecular nature of this brick, you'll need to know its form. This brick contains molecules. Molecules contains atoms. Atoms are made up of protons, electrons, and neutrons. If we zoomed in more and more, we'll find what are called elementary particles. Those particles are insignificantly tiny that we can see them, and they're the simplest particles in the universe. Why do you think we can't see elementary particles? Here's an easy answer. Anything you see is light. Light is an electromagnetic waves that hits a surface and reflect to your eye. But these elementary particles are so tiny that the electromagnetic waves passes through them and no light can be reflected. If you try to look very hard, you'll see a blurry image, but you can't see the particle itself. So we don't know yet what the particles look like. Well, a good question will be, how can we do researches on them? Well, they are unseeable. It was based on the fact that a particle is a point on a grid with 0 dimension. But unfortunately, gravity was a problem in the point particle theory, because gravity itself is a field, not a particle. It attracts the particles. Also, the standard model theory, which describes 3 out of 4 fundamental forces as well as elementary particles, does not define gravity. In addition, general relativity theory, the theory of gravitation, does not allow the results of the quantum mechanics to be true, because quantum mechanics places limitations on smaller objects while general relativity places them on larger objects, and that develops inconsistency. So physicists said that we need something that have dimensions and can unify all fundamental forces. By the way, fundamental forces are electromagnetic force, weak nuclear force, strong nuclear force, and gravity. So they decided to replace the points with lines or string, one-dimensional string, and that worked. The vibrational state of a string determines the particle, while the length determines the mass. We have 4 dimensions, 3 for space and 1 for time. The small problem is that string theory requires 10 dimensions to work in, but scientists imagined those dimensions, and they said that it would not be observed in their experiments. And some scientists say that those extra 6 dimensions are not observed in low energies and are not effective. At the end, string theory unified gravity and other forces together, which is a big thing that physicists and scientists tried to do it years ago. Scientists believe that it will be the theory of everything, which defines all physics aspects of the universe. And with the theory of everything, we can solve problems that mystify humanity.